Hey everyone. So we're going to do a more detailed lesson on arrays, because this is a topic that can sometimes be scary for people who are new to coding, but there's really no need for that. It is really quite simple. It's just a list of items, right? A list of different values. So, you know, there are different types and they have their different uses, but at the end of the day, if you hear something to do with arrays, it is just, instead of one value, it's multiple values. And a very simple way of knowing this that you've already probably been working with are vectors, right? So a vector is three values, x, y, z, okay? The components happen to have almost like a label, so x, y, and z, but really the first component, or the sort of zero index, is the x value, right? The first value. And then the second value, y, is the second. So it's basically the one index, right? It's in position 1 because it goes 0, 1, 2, right? But it is essentially just an array. It's just a fixed array. It's a fixed length array that only has 3 values. Whereas these arrays, they can be any length, so you could make them longer or shorter or whatever. But that is essentially all it is. Now with a vector, it's 3 different float values. But in our case, we can actually store any different values in there. It could be strings, or it could be integers, or it could even be a mix of them, including other arrays, and that's where it gets kind of complicated. But you know, it is still just a list of values, and that's all it is, right? So I'm going to talk to you about the different types, and then we're going to see how we can work with them, because arrays are going to come up very often while we're coding. This is not just some sort of outlying thing that we'll use occasionally. This is used literally all the time, so we have to get to grips with arrays. Right, so I'm going to create another one, so I'll call this my var, and let's create a list. Now I'm not going to do the numbers in any kind of order because I want to specifically show you the ordering. I'm going to actually give it a variety of different, let me give it the word 9 there, and then let me give it something else like a special value like a boolean, so false. So this is my list. It is square brackets. This shows what a list rather than a tuple or any other type, right? So if I refer to a list, it's a specific type of an array. Okay, so square brackets for a list. And then when we print my var, you'll see we get that same list. It's in square brackets, and important to note, it stays in the order that I entered it in. Okay. Lists are ordered, which means they maintain a very specific index order for every item, so they will not just shuffle around unless we tell them to reorder themselves. They are also mutable. You'll hear this term if you sort of Google anything to do with lists in Python. Lists are mutable. What it means is they can be mutated. In other words, they can be changed. You can add items to them, you can remove items, and you can replace items. So you could replace that with a different value. Both you can change the value, but you could also just replace it with a string. You know, you could literally swap it out with an entirely different value. You could drop this value and the whole list becomes shorter. There's lots you can do to it. It's basically open and allowed to be edited. Okay. Now lists are probably going to be one of the most common ones that you will use within your own code if you're going to create a list and then do stuff with it, because of course you need to be able to change it. Now there's another type, which is a tuple. These have round brackets. They are also ordered, so it will maintain a specific index order. The difference here is that this is basically a read-only list. Okay, so it works exactly the same, except that you cannot edit it. You can extract information from it, but you cannot add, remove, or alter any of the information inside of here. Okay, other than just simply deleting the list. You know, you can kind of clear it, but you can't actually change the list itself. This you will find quite common in your code, but a lot of the time you won't write a tuple. You will receive a tuple from another function, like from another method. Okay, so you'll run a method and it needs to return multiple bits of information, but functions can usually only return one value. So if it needs to give you 2 different bits of information, it will return it as a tuple. So there's a list of 2 different items, in which case one of them is the one value it wants to give you and the second one is the other value, right? So a lot of the time when you run a method, you're going to get a tuple out of it. Of course, you could write a tuple yourself if you know that it is for read only, because it has a lower memory footprint than a list. So if you definitely know you're writing it once and then just need to read from it, it's a good idea to make it a tuple. However, lists are much more flexible. The good thing though is that you can convert back and forward between them. So if you are given a tuple and you want to edit it, you can just turn it into a list and then edit it. But of course, then there's going to be a memory overhead for that. Okay. Next, we have sets. Now, in my experience, sets are less commonly used, especially sort of used long term. You'll usually convert to a set and then back from a set to a list or a tuple or something like that. Or you'll just extract some information after turning it into a set. So you don't usually, store it and then carry that list forward, like that set forward and forward and forward, right? You usually are just doing a quick conversion to get some information. Now, the first thing you'll notice here is that they're not kept in the right order. It has its own sort of internal alphanumeric kind of like a sorting of it, and that's just the way it prints it here. It just has no order, and if you try to order it, it will not work. Okay, so it will not let you control the order of those items. But the main use for it is essentially a kind of a Boolean list. So if we have multiple values inside of it that are the same, so duplicate values, it will remove those duplicate values. It can only have one 5, it can only have one 1.0, it can only have one false value over here. So if we had multiple, even a string, it is smart enough to detect that all of the characters are exactly the same, so it will not allow there to be a duplicate 9. But if I add another letter to the end of that, then of course it will allow me to have it, because those are not the same word. All right. So it's essentially a way of figuring out how many unique values there are within a list. The other functions that this is usually used for is you'll combine two different sets together with Boolean functions. Like you can essentially do like an intersect function or a difference function. So you're basically saying from this list and another list, which values are in common between the two lists, or which values are different in between these two lists or whatever. So if you're essentially wanting to assess two different lists and see how they compare and overlap, you can turn them into a set, and then there are functions that let those two sets be combined and give you those kind of answers. But typically that is what you're doing with sets, is you take a list, turn it into a set in order to get some kind of information. I have never had to, in my own code, build a set by like this, literally hard coding it with curly brackets. Typically, I will have a list already, and then I will take my list and turn it into a set in order to get the unique values. So maybe like drop all the duplicates, and then typically turning it straight back into a list. So you see here, you can actually basically typecast, right? So convert back and forward between these values. Now over here, you'll see when we print, it hasn't overwritten the original. It just returns the value. So we would have to say myvar equals, and then you basically turn it into a set, then turn it back into a list, and then store it in that variable. And now what it's done is it's still a list, but it has dropped all of the duplicate values. Okay, so we can take that back. Now we just have those 4 values. Of course, what the downside is, it does lose the order. So if the order was important, we have to restore the order. There is a way of restoring it, but it's a bit more work. So you got to figure out whether or not you actually this is what you want to do, or do you just want to count the number of unique values, for example. Okay, so sets are quite useful, but I would not say they are so common that you're going to use it in every line of code. But I promise you, in almost every bit of code you're going to use lists and tuples. And then the final one I want to talk about is dictionaries, which are also incredibly common. So dictionaries also use curly brackets, but they have a completely different structure, and they're a much more sort of complicated looking array. But essentially the main difference is, if you look at a list, these values in the list, so I'm going to get rid of this, are stored in a particular order. So every value has an associated index number. So this false value over here, for example, lives at position 3. because the first position is 0. So it's 0, 1, 2, 3. So the number 3 is associated with this, this value. Number 4 is associated with this value. All right. It's almost like showing up at the dry cleaners and you've got a ticket, you know, and the ticket in your hand says 5. Well, they're going to go in the back and get the, you know, whatever is, you know, the items associated with that ticket number. So 0, 1, 2, 3, 4, 5. Then they're going to come and bring you this value back from out of the back, you know, or like one of those coat check places or whatever, right? So that's a way to think about it. With dictionaries, instead of an index number to fetch the value or associated with the value, we are just tagging it with a string instead of a number. So we're not, essentially we're able to give it a label rather than a number. To use the dry cleaner analogy again, it's like instead of, you know, maybe the dry cleaner that I use doesn't have a ticket number that just has a 5 on it, it actually just has my surname on it. And then when I hand that to them, they go in the back and find the items that are tagged with my surname. Okay, that's all it is. It's just, instead of a number, it's text. But in order to write that, we use curly brackets, and then we have to label each of these as we go. Because it doesn't, you know, with the index numbers, it can just assume the index number, because the order that you give it the items in, it just starts from 0 and gives it a number. Here we have to give it the text because it can't guess. And typically this is used for things where you would want to label the information. So imagine I'm wanting to give details about a person. So we can say age and colon. So this is how the syntax for writing it. It's curly brackets, but it's different from a set because you actually give it these labels. It must be a string. So in ideally single quotes, you'd give it whatever the label is that you want, then colon, and then the value. Then a comma to separate it from the next value, which also needs another label, right? Now I keep calling them labels just because that's what you might understand it to be, but the actual word for this is a key. So this is called a key, and this is called a value, all right? So from now on, I'm going to refer to them as keys. So let's say this one was height, and we could make that 1.8. Okay, so average height person, well, actually, I'm sure a 5-year-old is not 1.8 high. Let's say he's 35, right? So age 35, height 1.8, and then let's say we would say maybe something like name, colon, and then their name is Steve. Okay, and I just wanted to show you that you can still have a mix of values. So you can have an integer, you can have floats, and you can have strings all stored within this. But the keys are all strings because they're labels, but the values can be a mix of values. And then over here, it could be something like, does Steve have blue eyes? And the answer is false, okay? And let's just get rid of this. We don't need that many values, okay? So now when we print, you'll see here is this dictionary, and it just basically lets us access that information using those particular keys instead of an index number. Now it is still ordered, so it doesn't rearrange the order, but the way we work with dictionaries is you don't access it using the index number. So if you tried to use it with an index number, it's going to fail. There are ways to sort of force it to fetch a value based on an index number, but that's not how dictionaries are meant to be used. So you can kind of go from a dictionary, convert it to a list, then fetch a value using index number, but that's not the point of them. The point is you can say, I've labeled this as the value height, and so when I want to access this person's height, I can simply ask for that value. Okay. Now we're going to talk about extracting information from arrays next, but I just wanted to show you the different types and how to write them. So we've seen how to manually build lists, tuples, sets, and dictionaries. Now let's talk about how to get information out of them. So now I've rebuilt a list over here and kept the dictionary so that we can kind of work with these two, right? Now let's say we want to access some information from one of our arrays. In my case, I'm going to just start with a list because it's simpler, and then we'll talk about dictionaries at the end. And this is really quite simple. You just use square brackets, and then inside the square brackets, you refer to whatever the index number is that you want to fetch. All right, so just like going to the dry cleaner and handing in your ticket, your ticket says, I want number 5, it's going to then give you number 5, right? So in my case, you feed it the list, and then in square brackets, you now give it an index number, but keeping in mind it starts from 0. So let's say we did 1, it's going to give us the second index in that list, which is 2.0, which you can see is right over there. Okay, so that's really simple. Keep in mind you can do it on tuples as well. So there we go, you can fetch it. It still works exactly the same because we're not editing the information. You'll see on lists, however, sorry, not lists, sets, they do not work. Okay, now this is actually the last time I'm going to talk about sets, because we don't use them all that often, and they're used in a very specific context. So I think talking about sets all the time is going to confuse things. Really, the 3 main ones is lists, tuples, and dictionaries. And really, tuples are just read-only lists. So if you really want to try to simplify this, there's only really 2 array types. It's just that this has a read-only version, and then there's a special type that we use only for comparing lists. So, simplifying it in your mind to there's these 2 different types. I either want to keep items stored by number, or items stored with an actual key. It's really easy to understand. Okay, so we can fetch an index number like this. Also, you can use negative numbers. Now, 0 is the first one. Negative numbers start fetching from the end rather than the beginning. But the number will tell it how far to come in from the end. But I do want to point out that -0 does not fetch the one at the end, because -0 and 0 are the same number. There is no such thing really as -0. Okay, I mean, I'm sure mathematicians will argue against that, but in this context, -0 and 0, same thing. So it's not going to fetch the one at the end. This will just fetch the first one. Okay, -1 fetches the first one from the end. -2 will fetch the second one from the end. 0 will fetch the first one. 1 will fetch the second. 2 will fetch the third, and so on. Okay, so now in this case, if I say -1, it's going to grab true. And this is very useful because sometimes you've built a list and you don't know how many items should be in it at the time of writing the code. Like, let's say you want to loop through all your points and grab a value, like the age of all of your particles. But you could have a variable number of particles on every frame. But if you want to grab just the one that's at the last created point, you can do -1, and now you're grabbing the one at the end, regardless of whether you've got 10 points or 1,000,000 points. Okay, so negatives grab from the end, positives from the beginning, but keep in mind that there is no -0. It just starts from -1 and goes backwards. All right, it's the same as some spare inputs in on your nodes. You'll see they 0 upwards, but then -1 is the first spare input, which goes into the negative. Okay, so fetching from lists and tuples, easy enough. Square brackets, and you give it the index number. Now, what's really nice is that's referring to a dictionary is actually done in exactly the same way. It's just square brackets, and you ask for the number you want. But instead of a number in this case, it is the key. So you just simply, in square brackets, ask for age, and it's going to print 35, right? Or you can ask for height, and it's going to give you 1.8. Okay, that's why it's super useful to store certain information in dictionaries, because you basically can go and say, oh, yeah, in your code, it's really intuitive to say, oh, look, I'm looking for the height of this person, and it just fetches the height value. Because at the time of storing it, you store it with a nice label. Now you can easily access that data. Okay, so calling it's really easy. Now, editing data is done in also a very similar way. Okay, so in this case, I'm not going to print it there. I just want to show you here for a second. So we're going to go back to the list. So I'll say 1 and my list. Okay, so my list 1. So what I'm going to doing is I'm calling my list, and I'm grabbing the second value, so not 0 but 1. But then if you say equals, and then you could say 3.0, what you're doing is you're overriding that value with a new value. All right, and then if we print my list, you will see that we have a new value. So this function over here actually alters the original. It doesn't just create a new version of the list that has 3 but doesn't overwrite it. So you don't have to say my list equals and then do this function, because you're just simply accessing that one index number from within it and then giving it a new value, and it overrides the original. Okay, so that's how we alter a value. Again, you can do this with negative ones as well. It's like negative values. And what's interesting here is you'll see that it was a Boolean, it's now overwritten it with a float. That's okay. It doesn't, none of these index numbers are locked to a particular type. It's just storing a value. So you're just replacing that last value with a 3.0 value. Okay. Likewise, in, so let's say we go age, myvar, and then you can override it with, so now let's say Steve has had his birthday and he has gone up by 1 year. Now you can say myvar, and you're just altering the age value to be equal to 35. So you're just overriding it. Of course, if you wanted to actually increment that based on what the value was before, so literally take all these people that you may have in this list and sort of increment their age, well, what you could do is fetch that. So you could say myvar age plus 1, right? And so now we're still going to get the result of 36, except that it's based on what his age was. So if his age was 25, now he's 26, okay? And actually, I'm not even sure if plus equals 1 will work. Maybe it will. Hey, it does. Cool. So you can just do the short form of incrementing that value as well. Obviously, that's only going to work with certain numbers. It's not going to work with, if we call Steve, then we won't be able to just plus equals a number. But you could plus equals string, and now he's called, oh no, not Steve, name, plus equals 1, and now he's called Steve1. So that's fun. Okay, so that is accessing and editing information in the arrays. Pretty simple. Now, something else I want to point out before we get too far is that lists, although they can store any number of different types of information, I also want to point out that they can also store other arrays, not just single values. So in other words, we can have nested lists, but it can even be cross-type. So it's not even just that lists can have lists. It's that lists could hold dictionaries, or that dictionaries could hold lists, or you could have a list inside of a dictionary, inside of a set, inside of a list, and it can go on forever. So here, for example, we could add, because we already have it stored as another variable, we could add myvar into our list. And then if we print myvar, you'll see our dictionary still exists. But if we print my list, you'll see that our list now includes all these values, including the very last value in that list is a dictionary. Okay, and accessing information within a nested array is done exactly the same way with the square brackets, but it's you got to remember that in the square brackets we're going to return a value. If that value is an array, then you can just put another set of square brackets to get values out of that. So in this case, I'll put -1 from my list to grab the last item, which happens to be a dictionary, right? Which you'll see there, it now prints that dictionary. And because I've got access to a dictionary, I can put just literally right next to it just another set of square brackets and grab blue eyes as the key, and it's going to give me that value, false, right? And if that value was another array, let's say it could be a dictionary within a dictionary, so I could just put down something like A equals 1 and B is 2. Okay, so that was another dictionary. Then that's the dictionary that would get returned there, and then we would be able to grab A from that dictionary and return just the number from that. So you can have as many nested kind of square brackets over here as you want to go deeper and deeper into any kind of hierarchy of lists within dictionaries or dictionaries inside lists and so on. Next, I'm going to show you a few good methods to work with arrays. So this is not going to be all of the methods. These are just some of the most common ones. Firstly, I want you to just see them in practice so you know how to use methods. but another reason is so that you can just kind of see some of the things that you can do with methods, because this will inform your code writing later down the line. You certainly don't need to remember all of this. There are a million resources out there. It's so easy to Google, how do I do this in Python, and there will be loads of answers. So it's more just so you can see it and get a sense of what you can be done with arrays, rather than having to just guess, and it can waste a lot of time having to Google it. Okay, so one of the first ones I want to show you is the len. Now this is actually not sort of a method, but it's a global, like it's a Python function. So just like how print, we run the function and wrap the arguments in circular brackets, whereas the other ones I'm going to show you will be sort of methods applied to a certain type. Okay, so you'll see the difference just now. So len is giving us the length of the array, which is the number of items in it. It is not the same as length, like we use in vex. There's a length function and then a len. Length is the length of a vector. Len is the length of a list, or like the number of items in a dictionary. Okay, so you can say len my list, and we could print that, right? So let me insert that there. So if we take the len of my list, it's going to be 5. Now the reason it's 5 is because there's 1, 2, 3, 4, and then 5 items in the list. Even though the 5th item is a dictionary, it still counts as only 1 item. You could open up that dictionary, so we could grab the -1 index, so the last item in that list, and now we're asking for the len of the 5th item of that list, which is the dictionary, and therefore the answer is going to be 4 instead of 5, because there is age, height, name, and blue eyes. Okay, so essentially whichever array you feed it, it's just going to give you the len of that. Now actually we can also check there's 0, 1, 2. So the position 2, in other words the 3rd index of that list, is a string. If we ask for the len of that string, it's going to give us 9, because there are 9 characters in the word something. So this is another way where strings can act like arrays. Okay, so that's the len function. It works both for dictionaries, lists, tuples. It works for everything. Okay, now moving on to some list methods. Now Python is object oriented, so what this kind of means is we can refer to an object. So these lists are variables, all of these are objects, right? And each object, based on the type that it has, will have a bunch of methods associated with that. So we can basically point at our list, so my list, and then run a method that's associated with lists. So these are methods that can be applied to all, or at least most, lists. There might be certain exceptions, but these are the methods for lists. Again, these are not all of them, but I'm just going to show you a few so you can see what useful things you can do. So I am going to, so it's mylist.count is the method I want to show you. Count is where you give it this is not counting the number of items in the whole list, that is our len function, but instead count is we give it one element value, so 5 for example, and it's going to count how many 5s there are in this list. Okay, so in this case it's only 1, but let's add a few at the end to see that this does work. There's a few 5s, it's going to come up with 3. Obviously I could then say 2.0, which is another item in the list, and it's going to find 1 instance of that value. If I said 2.1, it's just going to return 0. In other words, it has not found that in the list. So it's a way of counting how many there are, but it's also a way of checking whether or not there are any at all, because it'll just not, it won't error if you give it one that doesn't exist. It'll just return a 0, which is quite nice to know, because then you can use that in logic statements. Right, then index. So index is similar to count in that you feed it a value, so 5, but what this is going to do is tell us the position of the first instance of that. So there are multiple 5s, it's not going to return multiple answers, it is just finding that the first 5 exists at position 0, that's why it's returned 0. If we maybe give it the word something, it is now going to tell us that the word something does exist in this dictionary, in this list, and it lives at position 2. All right. And if we try and give it something that doesn't exist, so 2.5, for example, it's going to give an error. All right. So of course you can handle these errors in Python, and I'll show you how to do that later. But if you would want to just have a simple way of checking whether something exists in a list, index is not as good as count, because count can just tell you 0, as in there are none of them. Whereas this now, if it doesn't exist, you have to do error handling. Okay. Now I just want to point out that count and index both work for tuples as well, because you're not editing the list at all. So if this was a read-only tuple, you could still ask for the index and you could still ask for the count. Also, len will obviously still work on a tuple. So far everything we've done works for both lists and tuples, right? And len also works for dictionaries as well. But now we start to get to the point where we're going to alter the list, and so these will not work with tuples, but they will work with lists. Okay, so in fact, what I'm going to do is create a new variable here called foo, and instead of working within the print function, I'm going to just print foo, and then I'm going to work on a separate line here, mostly for neatness, but also because I want you to see what writes values into foo versus what writes to the original list. So in other words, does it return a value or does it alter the original? So if we say mylist.append, so appending is adding to a list that adds at the very end. So it doesn't let you choose where it gets added. It simply just attaches it right at the end of the list. Okay. So now we can say .append, and then we give it an element. So maybe I give it the number 10. And if I hit apply, you'll see what it prints is none, because we're printing foo. So this is one of those that does not return anything. It simply alters the original list. So I'm also going to print my list here. So you'll see it's printing none because nothing was returned and stored in foo, but then it's printing my list, which is now longer because it has the number 10 added to the end after the 2 5s at the end. All right. So that's how we append to a list. Then we can have insert. Now insert is doing a similar thing, so we can add 10 to this list, but it is allowing us to specify a position. So if I say 3, and so it wants 2 arguments, so the first one is the position, the second one is the value to be added. So we're now telling it we want this to be, this new value of 10 should be at position 3. So 0, 1, 2, 3. It's going to go here. So it'll be after the word something, but then everything else after that gets shifted down the line. So true will then become the 5th rather than the 4th. Okay. So if we do that, you'll now see again it prints none when we print foo, because this doesn't return anything, but it alters the original list. The original list has been changed now to have a 10 over here, and then true is the next item, and so on. Right, so that's how we insert. Then removing some items. Pop is a very commonly used one. So pop with nothing in as an argument is going to do 2 things. This method returns the value that was popped, and it alters the original list to remove the thing that was popped. Okay, and with no arguments, it automatically pops the last item in the list. Okay, so pop with nothing is taking this final 5, dropping it off the end of the list. So you can see our new list only has 1 5 at the end, not 2, and it returns 5. So this is a way of, you could use it for either way, or you're trying to essentially separate parts of the list out, and you could then store it in another variable or potentially add it to a different list. And so it's a way of saying, okay, let's take this item out of the list, add it to another list, and that's why it sort of does the double. It returns and it alters the original. Okay, but you can also choose to pop a particular position. So if you now say pop 2, then instead it's going to return something, which is that string, and then you'll see that something has been removed from the list. Okay. You can also remove an item, and this, you don't choose the index number, you choose the actual value. So let's say we want to remove true from the list. So you'll see it doesn't return anything like pop does, but it will go and find the first instance of this value, just like how count and index worked. So it's finding that value over there and it's removing it from the list. So you'll see after something, it just goes straight to the dictionary. It does, however, only remove one instance of it. So if we do have multiple trues, you'll see that the other one will remain, and you would have to run this again to get rid of true. Every single instance of the value true. Okay. Then clear. Clear just simply clears the whole list. Just empties the list and gives you a blank list. Personally, I don't really use this because you could also just say my list equals and then give it an empty list. You can easily override it. So I don't know really when you would want to clear, but if you want to, you can. Right. You can reverse a list. Remember, it is an ordered array, so it does let you sort of change the order of it, and it will hold that order, so you are able to specify that it should reverse itself. So now you'll see it's basically mirrored. So the two 5s that were at the end are now at the beginning. Then we've got our dictionary. Then we've got true something 2.0 and then 5. Okay. Now you'll see that it does not return anything. It just alters the original list. You can, if you want to, when you print a list instead, well, print, or I mean, we could even store foo equals, and then what we could say is reversed. So this is printed. This is basically taking a version of my list, but it's a reversed version, and storing it as foo, and then we can print that. But the thing is, it creates a reverse iterator object. So printing it doesn't really work very well, but you could loop through. So this is a way of saying you're going to loop through the list in reverse rather than forward. But it's not a good way of getting like the actual reversed list. That you can just say my list dot reverse, and then it's going to actually reverse the original list. Okay. Likewise, there is a sort function. This is getting more specific about the order that you sort the list. Now, it will not be able to do this with mixed types if you give it no arguments, okay? Because here with no arguments, it is trying to sort this list alphanumerically, but it can't do that. It literally can't have a mix of numbers and letters, and even so, it's now also got special types, it's got dictionaries, it just doesn't know how to put these in any kind of alphabetical order. Whereas if you only had numbers, so let's say we had all of that, then it would be able to sort that list, and it's going to sort it in increasing order. So 2.0, then 5, 5, and 5. So it can work with a mix of floats and integers, but it will not be happy with a mix of strings and dictionaries and everything. You could also have multiple strings though. So maybe test and whatever. There we go. And then it will put those in alphabetical order, but you cannot have a mix. Okay. So, but what you can do with sort is you can feed it a key. So you actually create another list of indices, and it's going to basically use that to reorder the list. So there are ways of doing that. That's getting quite complicated. It would probably be a whole lesson on its own because there's lots of cool things you can do with it. So we'll show that in future when we actually need it. Just know that there is a way of specifying a very specific sort order, but if you give it no arguments, it's just going to sort by sort of alphanumeric, but then of course it needs to have the same type rather than being a mix of different types, because it doesn't know how to work with those different types. Okay, so those are some basic list methods that you'll find quite useful. Just quickly moving on to the dictionaries. So my var, there's a couple of useful methods for working with dictionaries. Particularly pop does still work on dictionaries, so there is a pop function, but there is also a pop item function, and the difference really is that pop in this case will not work with it will not work with an index number. So if we give it no arguments, it's going to fail because it would need to assume, like it needs a it needs a key. You need to tell it which thing it needs to actually pop, and with no arguments it has no idea, and it will not just assume that it's the last one in the list. Okay, so you have to say you could pop age, and then it will work exactly as we expect. It's going to return the age value over here, and that's going to give us the sorry, I need to print my var over here. It's going to print the dictionary without age. So it's done exactly what pop did on the list, but it must have an argument because it needs a key. Now, if you want to be able to give it an index number instead of a key, then you can use pop item. And because pop item works with index numbers, if you don't give it any arguments, it will take the last item in the dictionary and pop it. So like that, it has removed that as a separate item and returned it. And you'll see it returns it as a tuple of the first index in the tuple is the key, then the second one is the value. And then it alters the original to no longer have that item, so you'll see the original is also one item less. But with pop item, likewise with pop on a list, you can also specify an index number, and then it will only remove that specific one. So in this case now, hold on, does that not work? Takes no arguments, one given. Oh, okay, no. So pop item only takes the last one. That's interesting. Anyway, I think pop item you won't usually use because it's index number based, and when you're working with dictionaries, you generally are just wanting to work with the keys. Otherwise, why would you be working with a dictionary at all? So pop is going to be the one that you're going to most likely want to use. In addition to pop and pop item, you can also clear a dictionary if you absolutely want to, and then it's going to just give you an empty dictionary. Now, there are three other methods I want to talk to you about very quickly. We're not going to go into super detail with them, though, because we're going to use them more in the next lesson when we do iterating. Because with lists, a lot of the time you want to loop through the list with dictionaries or with lists. But to loop through a dictionary, you need a little bit of help. You need some methods that actually help separate that into data that a loop can handle. Because a loop cannot just handle a dictionary on its own. So these methods I want to show you, one of them is items. So dictionary.items. What that is going to do is return, it's sort of a special object. It looks like a list, or it looks like basically a tuple, which is then a list of separate, like tuple pairs, where each one has the key and the value as a pair within a tuple. Okay, because this then lets the list loop through, and on the first iteration it will look at that tuple, and if you give it two variables, don't worry if this doesn't make sense, we'll see when we do looping. If you give it two variables, it can take the tuple and split it apart and store that in two different variables. So this is basically an object that is designed to be looped through. So it's a way of looping through our dictionary, as you have to say the dictionary.items. You can't just loop through the dictionary on its own. You can also specify that you want keys, which then gives you a similar object, but instead of calling it dict items, it's dict keys, and that is just going to be a list of all of your keys, right? But this is a special item, so it is not like a special object. It's not actually a list, but it can be turned into a list. So the fact is, let's say we try and do something normal that we would usually be able to do to a list, like because remember we stored this in foo, so I could do something like take just the last item in that list. It's not going to be able to do it. However, if I turn that into a list first by just wrapping it in a list function and then try to grab the last index of that list, then it's going to work and give me the last index of the list, which it's a keys dictionary, sorry, a keys list. So it's a list of all the keys from the dictionary, not the values, just the keys. So age, height, name, and blue eyes. Turns it into a list, and then the last item in that list is actually blue eyes, and that's why it's printed blue eyes there. Okay. And then, and you'll see, by the way, just our other print, it doesn't alter the original dictionary at all. This is just asking for a new list. It's building a new list. There is also one called .values, which does the same kind of thing, except it's just a values list. So if I just print foo, you'll see that it's a dict values list, and this is just, there's all our values but without the keys. Okay, so, and those can all be converted into lists if we want to, right? Even I believe the items one can also be turned into a list if we ask it to. Yes, so then there would be a list of tuple pairs. Okay, so there we have it. These are some useful methods for these arrays. In the next lesson, what we're going to do is some blocks. So that'll be like if blocks and logic statements, but we're also going to handle some looping, which means we're going to come back to these lists and figure out how, and like even more advanced ways of working with them using iteration. Okay, see you there.